and please continue with the talks.
Thank you, Arvind. Could you able to hear my voice?
Yeah, your voice is clear, sir.
Okay, let me share the screen. Is it clear?
Yes, sir. Now it is clear.
Yeah. So,
sir, one thing I would like to ask you, sir.
Yes.
If anybody having a doubt, can raise their hand in between, or at the last they should ask the question. So, in what mode you will prefer? Sir?
It's okay anytime. In between also it's okay.
Yeah, dear participants, is that if you have any doubt, any kind of query, you can raise your hand in between, and sir will definitely take your question. So thank you very much, and please enjoy the session. Thank you.
Good morning, all. Good morning, Dr. Arvind. You had a very nice introduction about me. Thank you for that. And this faculty development program that you are organizing, it's on manufacturing and automation. It is a very much need of important in the many of the industrial sector is concerned. People has to know what is about the different manufacturing methods that are being coming up in recent. That we need to understand. And this topic that I have taken is a mechatronic system for a smart manufacturing. So we all know about what is manufacturing. So manufacturing it is the process of transforming the raw material into a useful product. Okay. So the raw materials are being converted into useful product by employing the removal of unwanted material by different method of manufacturing process. So this is a basic definition of the manufacturing. Now, yes. Hello.
Sir, we are listening.
Yes. Okay. This removal of unwanted material from the raw material and making the product to the specific shape and size and accuracy is the manufacturing. Now we talk about, usually we have the 4 types of manufacturing process that are becomes very common. One is casting process, machining process, and metal joining process, and metal forming process. These are the fundamental 4 manufacturing process. The different product that are being manufactured by any one of the process appropriately, and that also depends on the material that you are using for making the products. Now we come about the smart manufacturing. So smart manufacturing it is being evolved more automated and computerized, as well as is complex in nature. Okay, the smart manufacturing, it is very popular in the current manufacturing sector. When we talk about the smart, so always the sensor will comes in picture. So the present manufacturing scenario is mainly consisting of smart manufacturing by employing sensors and computing platforms, communication technology, and the control system, and the data simulation, and so many things. So this basically utilizes, we talk about the CPS, cyber physical system, and many other things like Internet of Doing Things, cloud computing, and of course the artificial intelligence and data science. So employing all this technology together, we can make the manufacturing method very smartly, and which can be able to cope up with the today requirement of manufacturing. So when we talk about the manufacturing, the smart manufacturing have a 6 pillars. So the manufacturing technology and process that we are using in smart manufacturing, the material that we uses, data, and the predictive engineering, and the sustainability, and the resource sharing, and the network. So these are the 6 pillars of the manufacturing, smart manufacturing. So let us briefly identify what are these 6 pillars. Manufacturing technology and process. So the application of new material for the production of micro component, we require to produce a new manufacturing method so as to manufacture the component for the requirement. So like the additive manufacturing and the micro manufacturing methods are becomes used when we talk about in a conventional system of manufacturing like machining, milling, etc. So this additive manufacturing and micro manufacturing is a new technological development in order to produce in order to deal with the new materials and the micro component production, which becomes very popular in case of smart manufacturing. And of course the materials. So when the material development technology is coming up day by day, we have a large kind of material which are being very hard to machine, and to deal with such kind of materials, and also the material something like the shape memory alloy are functionally degraded material. So these are becomes very commonly used in smart manufacturing, and which are correspondingly the material manufacturing process are required to be evolved suitable for this material. And of course the data, the renaissance of data in the manufacturing has been now triggered by the development of sensors and the wireless technology and the processes in the data analytics. The predictive engineering is one of the latest addition in the space of the manufacturing, smart manufacturing scenario. And apart from that, the sustainability is one of the important aspect. So due to the global warming, so the every manufacturing sectors which are being involved in sustainable to manufacturing of the component, which basically takes up the 3 aspect. One is economic aspect, another one is environmental aspect, and then social aspects. Considering all the 3 aspects of manufacturing, so we need to design or derive the appropriate method for making the product. So that becomes a paramount important in case of smart manufacturing. Resource sharing and network as manufacturing, now it becomes digital and virtual. So the data sharing and the networking globally, it takes a very important concept, and that becomes very popular over here. So by use of the cloud computing technologies. Now of course the whatever the name that I mentioned in the 6th pillar, it is not only a simple name, it is these names also may be changing, depends on the degree of importance as the time changes. Because when we talk about the data as one of the pillar, so the data is nowadays becomes big data. So because it becomes integral part of the manufacturing, and in the smart manufacturing, so we call it as a big data. Similarly, the production planning and forecasting have been preceded by the predictive engineering and versed in the data science today. Now comes mechatronic systems. So whenever we talk about the smart manufacturing, we cannot keep up with the conventional manufacturing technique. Of course, we have evolved from conventional to a CNC manufacturing technique. The CNC partially have a mechatronic system of manufacturing, because everything is being computer controlled and no human being is involved in manufacturing the component. So basically the mechatronics becomes derived from the word mecha, from the mechanism, and the electronics from the electronics, that compose of mechatronics. So this is first developed in the Japan in the year 1960, and that time it is also being called as a smart system. You can find every application in almost all field of engineering, this mechatronics. The basic definition goes like this: mechatronics is the synergistic integration of mechanical engineering with electronics and the electrical system, along with the intelligent computer control in the design and manufacture of industrial product processes and operation. So to distinguish what exactly a typical mechanical system, how it differ from a mechatronic system. A typical mechanical system takes a input as the process parameter, something like pressure, temperature and force, etc. The system develops some output actuation. It may be a rotational effect or maybe a linear movement, etc. It is completely a mechanical system. Okay, so some parameters inputted to the system and the output action is being generated. Whereas in case of mechatronic systems, we have sensors, actuator and a microprocessor based controller. It is a electronic system and the actuator either may be mechanical or the electrical devices, and apart from that we have a sensor. The sensor senses the process parameter in the system and provide the signal to the microprocessor controller. So the microprocessor based controller are being stored with the appropriate program and in its memory, which also can be varied by the input information by the human being, and based on this appropriate program and the signal received from the sensor, an output signal is being generated and that is being implemented in the actuator in order to execute a particular action in this system. So this is how the sensor and the actuator along with the electronical based microprocessor controller is employed in the mechatronic systems. Now the main components, as I told you, these are three main components: sensor and microprocessor based controller, or we call it as microcontroller. It's a completely electronic system. Sometimes we also call it as a programmable logic controller, PLC system, and then the actuation system. Consider this is the plant in which we wanted to have a control over so many parameters. So the plant either may be the process or plant may be either a robot or maybe autonomous guided vehicle AGVs or maybe a numerical control machine and consumer product like a washing machine or anything else. And similarly, all kind of things can be a process, and this process in which the parameters becomes continuously varied, which are becomes monitored by the sensor system. And these sensors takes a parametric variation and generate an appropriate sensing signal to the microprocessor controller, and which generate an output signal to the actuator. The actuation will be carried out and that will be implemented in the system. So this is how the simple mechatronic system is being implemented in many applications. Okay. So a typical mechatronic system have many applications. So these are a few of the applications. The industrial robotic system, all of us we aware of that. So automatic manufacturing equipment, many commonly used CNC system and the flexible manufacturing system and GT cell, etc., which completely in the form of the MCU, the MCU of the CNC system and FMS, which takes care of the automated material handling system and a centralized computer system, which are in the form of the mechatronic systems. And aircraft navigation, this is the first application where we find the mechatronic system. And in many automotive sector, we have many applications: automatic fuel injection system and the vehicle control and anti-lock braking system. And of course, the home and office appliances, the many equipment like washing machine, induction stove, office appliances like a Xerox copier, printer are becomes very common. Okay. Now, the main advantage of the mechatronic system, it is having high level of integration with the other components. That is a very important advantage, and it uses more electronics and software that makes the use of artificial intelligence in the system, and which can be controlled very comfortably. And of course, the microprocessor can be reprogrammed and it can have an increased functional capability, and then better design is possible. And which are considered to be a comparatively the mechanical system. The mechatronic systems are cheaper and compact in size, and the mobility, lighter weight, and these are very advantages of the mechatronic system. Now, what is microsystems? So whenever we talk about mechatronic system, nowadays it is scaled down to a micro level, because we wanted to have a very miniature in the component. So the miniaturing of the system becomes very popular due to compactness. We wanted to manufacture the product as small as possible, like mobiles, which have a lot number of options that are being provided in that. We have telephonic option and Xerox option, and so many options are being composed in palm tack and mobile systems. So this makes the mechatronic system to manufacture in terms of a micro component. So micro system generally consisting of whatever the component that we have in the mechatronics, it will be there. It is a micro mechatronic system basically, and we have a sensory systems, and then we have actuator, and as well as we have the power supply will be there, and the signal and transaction and the processing unit takes signal from the sensors, and it is being processed in the circuitry, which are being composed in a single unit, and that will be implemented in the actuator. There will be a basic power supply from its outside, and this constitute a micro system, which we generally identified as a micro electromechanical systems. So micro sensor, actuator, and the signal transaction and processing unit becomes the three main components of the micro system. The micro system typically, in case of the meso scale, it will be a micro and macro scale. And when we talk about the intelligent micro system, in which there will be a microcontroller, and the entire sensors and the actuator unit becomes available nowadays in case of a single chip. It's the single silicon chips, which is always we call it as a lab on chip, which will be very smaller in size of 0.5 by 2.5 millimeter. The most of the microsystems are generally being designed by a single function, but the intelligent microsystems becomes popular in the industry, which takes care of many function, and it is also works on the closed loop control. So we have a MEMS systems, and the MEMS systems provide appropriate signal to the controller, and which are being conditioned by the signal conditioner or processing unit, and this execute this is being executed the output signal by the actuator, and the actuator produces an output measurement. And also we have a closed loop unit over here. The actuator, what exactly the control is become to be achieved, whether it is exactly achieved or not, that also being monitored by a signal processing and a measurement, and there will be a comparator, and this is being compared with the desired signal, and the error will be again generated. This becomes also a closed loop signal. So the entire things being composed in the form of the single chip and in the form of silicon chips, and which forms an intelligent microcontrol system. Now moving on to some of the applications of the mechatronic systems. So we commonly, micromechatronic system, we commonly aware of the airbag deployment system in case of a vehicle, automotive vehicle accident system. Whenever we have vehicle collision, we use this air deployment systems. So this particular system consisting of crash sensor. It is having a crash sensor, and which works as on the principle of micro accelerator. And during the vehicle collision, the crash sensor subjected to a jerk, which is be built by the accelerometer, and this accelerometer generate a signal to a microcontroller system, which basically explodes some chemical, and this chemical generate argon or I mean nitrogen gases that becomes filled in the bag, and that it becomes elongated, it is becomes big, and this prevent the saving the any incident that occurs due to jerk in the systems. So the vehicle collision is become prevented, and this becomes very popular in case of today automotive systems. So this is one such kind of application. And we have the other application like in case of micro mechanical systems, which is a micro gear. So these micro gears, which are very smaller in this size, which are significantly small, and the pitch of the gear is becomes in the order of 100 micron. So these small gears, which are being used as an actuator in the micromechanical system, and which are being usually produced typical LICA process. So this is a sophisticated process that we usually manufacture, and such a small gears also becomes available. This is a micro motor, and this is a electrostatically driven motor, and this is also being produced by the LICA process. It basically have a three component, a stator and a rotor, this is a central gear, and a torque transmission gear will be there, and the size of the component will be in the order of like 120 to 750 micron of sizes. The height of the motor is also very small, it is of 120 microns. So yes, micro motor, which the components are being generally being produced by the LICA process. So this is a turbine, micro machined turbine. It produces generate powers. The components are becomes all of nickel component. The gap between the axle and the rotor is are very small. It is in the order of 5 micron. The height of the turbine is also 150 micron. Rotational speed is very high, as more than 50,000. It has due to steel and very hard material, lifetime is very much higher. Similar kind of many electronic components are becomes designed and which are being manufactured in the smart manufacturing systems. Coming to application of the healthcare sector, mechatronic system in the healthcare sector. So disposable blood pressure transducer, which becomes very common. It consisting of sensory devices which is being used for monitoring the patient in the intravasal and the intracranial blood pressure monitoring. So it is usually a very low cost and lightweight. It is designed to give a consistent and accurate reading about the blood pressure, usually in the range of -50 to +300 mm of mercury. This blood pressure monitoring systems are becomes very common, and which are being available in the form of pressure gauge kits, and this becomes very it have a good market and it is highly demanded. The annual production cost will be 17 million and the cost is $10. Then intrauterine pressure sensors. So this is being used in case of a child delivery. It is being used in case of child delivery. There will be a catheter. So there is a catheter and there will be a sensor inside that, which is being inserted into the baby place, and the catheter uterus. It is inserted into the uterus and which accurately measure the pressure level inside the uterus. Whenever the pressure during the child delivery, during either contraction or big period, the pressure inside that will be vary, and depends on that the variation in the pressure can be monitored, and based on that we can identify, we can prevent the cause of death of the child during the delivery, both by the pregnant lady and the child. So this is also highly demanded in the market. Its market demand will be more than 1 million per year. Now, This is a very life-saving a mechatronic system. It is a pressure sensor. Angioplasty, we all heard about the angioplasty. Angioplasty is nothing but to prevent the artery blockage. Whenever we have a cholesterol in the artery, so which we wanted, which prevent the blood flow in the artery system of the heart, human heart, and which are being rectified by inserting a stent inside the artery system. And whenever this stent is provided, so there may be a possibility that further damage of the entire system. So there will be a catheter is being inserted with along with the sensor system over here. So this is a pressure sensor, this is a catheter, and the catheter inside the stent system, it is being permanently provided over here, and there will be external antenna will be there. So this catheter, whenever there is a collision in the system, even when you provide the stent, there will be a heartbeat will be a variation. So if there is a normal places, the heartbeat will be at this point, it becomes big. When the heartbeat becomes preponed, so the peak occurs sometimes before that. So the variation in the pressure system becomes monitored by the pressure sensor, which are being informed to the hospital by having a RF transmitter reader. So there will be an external antenna system, and this information will be directly from the human side, it will be directly communicated to the hospital via network. This becomes very popular in case of foreign countries. So that way, so the pressure sensor which monitor the blood pressure inside the artery, human artery of heart systems. So this is also very highly market demand. It is 5 lakh unit per year. So similarly, so the application of mechatronics and micro mechatronics system, it's not limited to only these few examples. It have a variety of application, the infusion pump pressure sensor, respiratory system, and of course we all know about the kidney dialysis equipment and the lung capacity meter, artificial heart system, and the human care support system, and these are becomes very commonly used industrial mechatronic systems. Now coming to the application of the consumer application, so the mechatronic system also not limited to only that particular automotive and other things. In the consumer applications, it have a hydraulic actuation system and the refrigeration system and the telephone cable leak system, how to detect the cable leak in the telephone system, because the telephone cables are under the floor, so the cable leak system need to be monitored to identify exactly where the leak occurs. So we have a telephone cable leak system without evacuating the cable from the earth, and then water level control system and the optical switching and fiber optic coupling and digital tire pressure gauge and the automatic cushion control and the spot systems. So these are way that the mechatronics and micro mechatronics system, we have an application almost in all field of engineering. It medical field, automotive field, consumer field, office, automation, and etc. Now coming to the some components of the mechatronic system. So one of the important component is sensor. Without sensor, we cannot extract the information of the ongoing process. It is basically a device that measures the physical quantity. That means physical quantity of the process, maybe a temperature, pressure, force, load, etc. And this physical quantity is being converted into an appropriate electrical signal, usually in the form of voltage. And this sensor provide the information about the variation of the physical quantity of the process in the form of electrical signal, which can be monitored, and accordingly the action can be taken up. So That is the main objective of the sensor in the system. The input to the sensor from the process and the output from the sensor is given to the microprocessor controller. Usually the output of the sensor may be, if in case of analog, it will be converted into a digital signal, because the microprocessor controller will always accept only the digital signal. Okay, and here are some of the sensor system that are being used in case of the commonly used sensor systems. We have LVDT. LVDT means it is a linear variable differential transformer. It is being used for displacement and position. And this next one is electrical strain gauge. So it is being used for converting the forces into a appropriate value. Value of the forces can be measured. And the pi metallic strips, it is used to identify, it is a binary sensor which measure the temperature of the system and takes appropriate action. And this is photoelectric sensor. So these are the 4 category of the sensor system that are commonly used in many of the mechanical, many of the mechatronic systems. So this linear variable differential transformer is basically a inductive pickup transformer. It is similar to the construction of the transformer. It has a primary coil and it has a secondary coil. That is, there are 2 secondary coil which are being connected in serially, and there will be a iron ore in its center, which causes a inductive coupling between the coils. The coil is supplied with the primary coil supplied with the voltage, and whenever the core is exactly at the center, so this core is being connected to the outside, and this core, when there is a displacement occurs in the system, which can be sensed by the core, and when the displacement of the system transmitted to the core, which the core will has a motion. When there is no motion, if the core is at center, there is no changes in the output voltages. So the output secondary voltage between the 2 secondary voltage, which cancels out each other, and that identify there is no displacement. When the core moves either towards right or left, according to that, the voltage will becomes maximum with respect to the other secondary volt, and that will give you the exact linear displacement of the systems. So the accuracy, we can measure it plus or minus 1 mm, and the resolution generally will be in the order of 0.01%. So the output will be in the form of voltage which varies from 0 to 10 volt. So this is being used for being very commonly used as a displacement sensor. So this is a electrical strain gauge. It is a resistive pickup sensor, and this works on the principle of resistivity. So whenever the current flows through a conductor, so automatically there will be changes in the resistance, and if there is a change in the force which causes lengthen the length of the resistors or contract the length of the resistor, automatically there will be a changes in the current or voltage flow, or changes in the resistance, and the fractional changes in the resistance will give you the it is directly proportional to the strain that the strain gauge is subjected to. When you apply a load, so automatically the change in the length of the resistance will cause us a fractional changes in the resistance, and thus that is being proportional, and that way we can measure the load or pressure or similar kind of thing, and which can be monitored by using a strain variation in the system. So this is being electrical strain gauge. So this is a pi metallic strip. Pi metallic strip, it is a binary sensor. So here in this case, there are 2 metal strips which are being fastened together, and one will have higher thermal conductivity, thermal temperature coefficient. Another will be having a low thermal temperature coefficient. When both are being fastened together, and it is being fixed at one end and free at the other end, and there will be a contact of the electrical contact in order to make a supply of electrical current to any kind of electrical system. So whenever this bimetallic strip exposed to heat, then automatically the higher thermal coefficient material will bend more, and that takes the low thermal coefficient materials also together, because of both are fastened together, and thus the contact becomes removed. So this is how the heat increase will cause us breaks the contact. Or similarly, we also can provide whenever we wanted to make the contact due to increase in heat, that also can be provided. So only we have to reverse the contact. So that way, this bimetallic strip is being used to monitor the temperature, and accordingly take appropriate action. It will only take an action either to make the contact or break the contact. When the heat level becomes low, automatically it makes the contact. When heat level more, it breaks the contact. So this we commonly use as in case of a iron box, electric iron box. Whenever the heats up, automatically the switches current supplied to the heater of the electric iron is being cut off. So this is a bimetallic strip of transducer. This is a photoelectric sensor. So the photoelectric sensors consisting of photodiode at one end, and there will be emitter on the other side. The photodiodes continuously transmit the light to the emitter. Whenever the object, so this is the conveyor, this is the object is coming on the conveyor. One side we provide the photodiode, other side is a emitter, and when the light signal breaks due to travel of the object in the conveyor, then the emitter will cut off the signal, and this information is being sent to the controller in order to count how many times the signal breaks, and that many number of times the object becomes traveled in the conveyor system, and thereby it is also used to count the number of components that the produces in the automated manufacturing system. So this is a many way by we can provide this photodiode and the photoelectric sensor system, which becomes very commonly used in case of continuous production systems. Now coming to the MEMS and the micro sensor, there are two things, micro sensor and MEMS. Sensors are very common in all mechatronic system, and no system can be provided without any sensors. So the difference between the sensor and the micro sensor is only the physical dimension. Micro sensors also sensor, but it has at least one physical dimension in the sub-millimeter level. So it is a very smaller in nature. Okay, so here is the gears, and there is a pin joint over here, and these components are manufactured by the micro manufacturing methodology. Similarly, here it is also slider and hinges, which are being very miniature in nature, and these are being manufactured by the earlier we have sensors and the circuits which are not being generally integrated. Now in the MEMS system, so micro electromechanical system, so which includes both sensors and the electronic circuitry along with some mechanical actuation system, that becomes the MEMS. So that makes the MEMS. It is a device that micro sensor and mechanical parts along with the signal processing units are integrated with signal processing circuit, and these are available in the small piece of silicon. So this becomes very common in case of modern smart manufacturing applications. Now coming to the action of the actuator. The actuator, it is an execution part of the control signal that are being generated from the microcontroller. Okay, so the actuation system consists or the elements of the mechatronic system which are responsible for transmitting the output of the microprocessor controller into a control action. So yeah, typical actuation system will consisting of an actuator which may be of electrical or mechanical or smart actuator, anything. The command from the controller is being inputted. The actuator will receive a power supply, and it will be connecting, it will generate an appropriate action to the external environment through some coupling mechanism. So this becomes the complete actuation system. Okay, so this complete actuation system, we have different types of mechatronics actuation systems. So these are the mechanical actuation system which are commonly used in a mechatronic. So it is a gear transmission system. It may be a spur gear, helical gear, or worm and worm wheel, or epicyclic gear train. So the input is given to one element and the output is generated. Okay, and this also may be a chain drive or cam drive, etc., which also comes under transmission system of a mechanical transmission system. And this is a ratchet and foul mechanism. So which have there will be a ratchet. Whenever the ratchet will rotate, so it will click only a finite motion of the rotation, and every instant of time when the signal is being provided to the power. So this is ratchet and bow, and this is turret mechanism. A turret mechanism which is being used to rotate the turret to finite angle of rotation. There are 4 slats are there. So every time when the signal is being provided, it rotates through a 90 degree. So that way, if the number of slots are becomes more, the angle to which the turret rotate can be varied. So this is a recirculating ball lead screw. This is the lead screw that we uses in case of CNC turbo drive system. In order to move the turbo drive system, there is a ball. The ball will be continuously recirculated in order to reduce the wear and tear between the lead screw and a half nut mechanism. In case of a conventional lead screw system, we use a circular ball, spherical ball, which can transmit continuously so that the turbo will move, and this takes the friction and the wear and tear becomes very minimum, because it have a point contact or line contact with respect to the lead screw and the nut system. So these are some of the application of mechatronics mechanical actuation system. Similarly, we have an electrical actuation system. The electrical actuation system, we have a solenoid controlled direction control valve, because usually the DC valve that we uses in order to move the fluid flow in a hydraulic system or pneumatic system. So the valve spool is moved linear direction, for which we have a plunger system in the solenoid, which will be pulled or pushed, so that the valve spool of the DC valve will be occurring different position in order to make the flow of the fluid in the system. So here particularly we have an electrical relay. So whenever the electrical relay is energized, automatically the plunger is pulled inside, and which causes the alternative position of motion in the system. So this linear plunger will move in and out, depends on the energizing of the solenoid. So the electrical supply to the solenoids coil becomes taken up from the microprocessor controller. The microprocessor controller will generate an appropriate signal. That appropriate signal are in the form of the connecting either the electrical connection or supplying the current to the coil. So this is a solenoid controlled DC valve which are being used as a electrical actuation system. It is a relay system. We all know about the relay system. So here also the current supply makes the relay to contact or breaks the contact, and there are many systems. This is a stepper motor and the DC servo motor. It is a continuous motion. We wanted to have a continuous motion, so we can have this kind of electrical actuation system. And we have pneumatic or hydraulic actuation system. Pneumatic uses air and the hydraulic system uses hydraulic oil, and this becomes very commonly used in a continuous or manufacturing system. And this basic actuation system consisting of a power source And of course, the power source which generate the power is nothing but the hydraulic or pneumatic power. It is a pressurized oil will be generated, and then this pressurized source of energy will be used in the valve in order to manipulate to appropriate action. And these valves may be of three kind. It may be a pressure control valve, or the direction control valve, or the flow control valve. The rate of flow of the pressurized fluid in the system control the load that we can able to take up, whereas the direction control will take care of the appropriate system unit to be activated, and in case of the pressure control, in order to control the system pressure. Okay, so this is being implemented in the actuator system. So this actuator is basically a linear actuator or rotary actuator. So we have a complete classification over here, and the linear actuator will identify a linear motion. Pressurized fluids enter at one end of the piston, and the cylinder will extend. There is a piston will extend, and that causes the linear translation, linear force, and in order to perform certain function. And to reverse back the cycle, so the fluid is entered in the rod end, and the blank end of the cylinder is returned back to the reservoir. So this is a linear actuation. Similarly, we have a rotary actuation. We have a rotary actuator system. There are three rotary actuator systems are very common. So gear type, and the axial piston motor, and the van motor. So the van motor may be a it is a either maybe a balanced type or unbalanced type. So which generate, it takes a hydraulic fluid, pressurized hydraulic fluid into the system, and the causes a rotational motion, and this rotational motion will becomes output from the motor, and which is being coupled to the other appropriate unit in order to rotate the component. So these are the different pneumatic and hydraulic system. Of course, due to limitation of the time, so I confine to only a few slides about this hydraulic and pneumatic actuator systems. Now, the smart actuators are becomes very commonly used in case of the smart manufacturing system. It is nothing but unlike the other conventional actuator, the smart actuators uses smart materials. Smart material means the material that responds to the environment and then undergo some changes in the material property. Okay, so this property change is being used to create the actuator or sensory effect from the material without any additional control of electronic circuitry. Okay, usually the alloys are alloys of nickels and titanium that generally being undergoes phase transformation. So whenever it goes for phase transformation, so when it is being subjected to a thermal field, it may be a heating or cooling effect, it's subjected to a thermal field. When it is being heated, so it goes for it is being programmed to a particular shape. Whenever it is being heated, it return back to that. And that way, the programmed temperature to which the material changes its shape due to the phase transformation, and thus these are becomes very commonly used as a shape memory alloy. It is being programmed as a semicircle, and then this is very commonly used in dentist, orthodontics, and other tensioning devices when we wanted to apply it. So these materials are becomes used as a actuator. And this is a piezoelectric actuator, piezo which are being used as a semiconductor thin film. There will be a semiconductor film at the top as well as the bottom. And whenever the electric voltage is applied across the conducting film, then the crystal expands. So when the polarity changes, the crystal contracts. So due to the changes in the polarity, the change in the crystal, we have the changes in the motion in the systems, and this causes a tension or the compression system. So this is a similar kind of piezoelectric actuator which are being used as a micro manipulator, because this is a small device. So whenever it is being held inside the human body, So whenever we wanted to inject medicine into a human body cell at every time when there is a need, so here we have a chamber, and this chamber we have the photoelectric, it has the shape memory alloy material, and this shape memory alloy material in which we have a control, and when it is being controlled, so automatically it enlarges. Whenever it is enlarges, it changes, it becomes the compressed the fluid chamber, and that the medicine will be injected to the needle into the particular part of the human body. So this is a way that the micro manipulators which are being used in the human body to inject the fluid medicine becomes very common. So now coming to manufacturing of this micro component. So micro manufacturing system, it is usually of three kind of manufacturing: bulk manufacturing, micro manufacturing, surface micro manufacturing, and Liga process. These are the three category. We'll discuss about only these three category of manufacturing of micro component by using in the mass. So the bulk micro manufacturing system, it involves the removal of material from the bulk substrate and obtain the desired shape of three-dimensional microstructure. It is similar to that the sculptor shaping the sculpture. Just we will be having original raw material from which we shape the required shape so as to obtain three-dimensional structure. So the main features are the manufacturing process will become straightforward and is less expensive, and it is being suitable for less geometry, because removal of material must be very low, and usually the manufacturing of micro pressure sensor dies, etc. And it is also limited to low aspect ratio of the component, because the surface dimensions are much larger than the depth. So this becomes overall height of the microstructure is limited only by a small thickness, and usually a silicon wafers are becomes generally being processed in the bulk microprocessing systems. Now this bulk micro manufacturing system, it is of again two kind. So here we have a silicon wafer, and this is a substrate, and this is a mask that we provided. So whenever it is being put into the etchant solution, so automatically the substrate is reaches to a depends on the mask shape. Okay. So there are again it is of two ways that we can manufacture the component. One is isotropic etching process, anisotropic etching process. Whenever it is being provided in the etchant solution, in case of isotropic etching process, it also erode the material both in the vertical direction as well as horizontal direction. But it will if it takes for longer period of time, then the undercut also will be in the substrate, and that by this shape of the component will lose its requirement. But whereas in case of anisotropic material, so the etchant will have the action of removal of the substrate only in the vertical direction, any one direction, either vertical or horizontal. So this is the two way that the anisotropic and isotropic of etching process that are becomes used in case of bulk manufacturing system. So surface manufacturing systems, it involves the removal of substrate material by in the form of gases etchant without wet chemical and wrenching. It will be there is no wetness, because the bulk manufacturing we use etchant which are the substrates are subjected to wet chemicals, but here there is no, it is only gases. The plasma is being used as a neutralized agency, and that carries the cases of the free electrons from the positively charged ions. And the plasma, there will be one end, there will be a wafer. This wafer we wanted to create the manufacture, the surface manufacturing, and which is being provided inside the chamber. And the chamber we have a plasma is being generated between the positive and the negative ions, and which moves from positive to negative. The plasma etching that converts the solid silicon wafer directly to a gas in a low temperature systems. The entire etching is performed without material ever coming in contact with the fluid, or there is no physical contact will be there. So organic and inorganic polymer materials can be easily etched by using this surface micro manufacturing process. These are the components that are being generally electronic components that are being generally being generated by using a micro. So small holes are being generated over here, which are being generated by the micro surface micro manufacturing methods. So here basically the surface substrate is masked to identify the etching surface. Carrier gas is argon is being used. The etching substrate is due to bombarding of high energy plasma ions, and which are react with chemically, and subsequent vaporization of the substrate of the material. So the materials will be always evaporated inside the chamber, and thus the corresponding format, the holes are becomes formed over here. LICA process. LICA process, it is the name is of lithography. It means lithography. Galvanoforming is nothing but electroplating, and the upforming is nothing but a molding. So this process is most commonly used in many of the microelectronic components preparation. So the fabrication process is completely different from the bulk and surface manufacturing, micro manufacturing method. It generally produces high aspect ratio of component. The depth to surface ratio will be more, and the micro components will be in the order of 10 microns are commonly used, manufactured by this. The gears which are becomes of 10 microns. So how small it is, you can think of it. So this uses deep X-ray lithography in order to manufacture the component, and the process is something like this. So in the process, we basically suppose that this is the gear that we wanted to manufacture. So micro gear we wanted to manufacture. So depends on the height. So it is high aspect ratio because this component is smaller in size, depth of the component is more. Okay. So with such kind of components cannot be generated in case of the bulk manufacturing methods. So that is why LICA is being very comfortable for manufacturing a high aspect ratio component. We usually generate a PMMA material, which is generally a photoresistive material, which can be used. The substrate is created for making the mold for the generating this component. So this is a PMMA material substrate, and this is being placed in under the metal. Okay, so there will be a masking. The masking is provided above the substrate, and the X-ray is being passed on through the masking. So if there is a gear shaft, so the gear shaft is being provided. Whenever the X-ray passes, so the due to the cavity, so the substrate is being material, the PMMA material that receives the X-ray or becomes evaporated, and thus this becomes a cavity, something like that. So this is a substrate that generated a cavity, and this becomes the mold, and this mold is being used for preparing the gear by using an electroplating method. So whenever electroplating is provided in order to fill the mold cavity by using a metal, then automatically the cavity is being completely filled and it becomes available like this. Now only thing is that we have to remove the substrate, and thus finally we will be availing with the gears like this. So these are we need to prepare a photoresistive structure, that's a PMMA structure, and we need to mask it and allow the extract diffraction. So it is a deep extract diffraction, because so that it can reach till the highest height of the deep structure, and the exposed portion of a PMMA cast and is being by the X-ray diffraction. Then the mold cavity, once it's ready, the electrode deposition is being carried out and the micro gear is being generated, and which will finally stripped out by removing the photoresistive material, and the gears will be generated. So this is a way that the Liga process is commonly used for generating a high aspect ratio of micro component in the mechatronic system. Now, another important factor that the controller, the PLC controller, that becomes very used as one of the component of the mechatronic system. Here I have generated one case study of our student project. So in which we design a PLC controlled pneumatic operated parts segregation system. So this is very commonly used in case of the automated manufacturing system. Consider that any kind of packaging industry or bottling plant, etc., which generate which packs the box, and the boxes will be of different in size. So which are being coming on the conveyor, the different sizes of the boxes are coming on the conveyor, but when it need to be segregated, so we need to segregate this based on the size of the box, and for which an automatic PLC controlled systems are being generated. So this is the problem of this particular objective is it consisting of a flat bed conveyor and an electric motor, and which carries high boxes and low boxes which need to be segregated. And there will be a proximity sensor is being used in order to sense the boxes based on their height. So the proximity sensor will input to the signal to the PLC controller systems. Then the actuator that we uses, it's of a pneumatic actuator. It is a simple piston and cylinder assembly which takes care of appropriate action, the actuation of the cylinder by using a solenoid controlled valve, and which takes care of removing the boxes from the conveyor system whenever the PLC controller direct the actuator through a solenoid actuation system. And this solenoid actuation system is being executed, and that acts the actuator system. Now, these are the physical representation of the statement. So here it is a flat bed conveyor, and the conveyor run by the conveyor motor, and here we have a proximity sensor. The conveyor convey the high boxes and the low boxes, etc. And whenever we wanted to segregate, so we can allow the low boxes to go exactly in the same conveyor, and the high boxes we can remove from the conveyor. So to remove the high boxes, so we have a sensor system, and the sensor system gives a signal whenever the high boxes comes in particular position near to the hydraulic cylinder. It gives a signals to the PLC controller systems. PLC controller system, and the PLC controller is having an input as well as output module. So it receives signals from the sensory systems in the input model, and it is being programmed what appropriate control signal to be generated at its output model, and accordingly it generates an output model to activate the electrical current supply to a 4/3 direction control valve. So this direction control valve control the supply of the pressurized air to either blank end of the cylinder or the rod end of the cylinder, and thereby it causes the actuator will be moving forward or moving backward. So these are the two solenoid system, and this solenoid, the energizing of the particular solenoid will cause either forward direction, or the other solenoid will cause us retraction direction. So in order to push the high boxes from the conveyor, we ensure the energizing of the solenoid, and so that the cylinder will move forward and will push the boxes from the conveyor. Okay, so this is a pictorial layout of the entire system, and this is a problem statement. So what exactly the motor is continuously operating, the conveyor is continuously working. Whenever the sensor is being sensed, the high boxes, automatically the motor stops and the conveyor remains switched off. When the conveyor remains switched off, then automatically the cylinder, the hydraulic cylinder is displacing the boxes from the high boxes from the conveyor system. It extends the and displayed from the boxes, then it retract back and thereby it completes the operation. And once the operation is completed, then the motor will be continuously rotating. So this is a motor and the position of different steps of the motor as well as the actuator system. Everything is explained here. M minus mean motor stops rotation, and the A plus pneumatic actuator extends the actuation, and this pneumatic actuator retract the actuation. M plus means motor again starts. So this is a positive, this is negative. Okay, so these are the different steps of the process. This is the appropriate, the entire system is represented in case of circuit diagram. So this is a 4x3 DC valve. This is the FRL unit, filter, regulator and lubricator to supply the pneumatic air into the system. This is a hydraulic system. So here it's a programmable control logic which is connected to a solenoid system, one for the displaying, another for retracting the solenoids. Okay. This signal flow for controlling any automated process is achieved by designing its a controller. सर मैं थोड़ा ऑनलाइन लेक्चर में हूँ, थोड़ा मैं बाद में फोन करता हूँ आपको. The signal flow for controlling any automated process is achieved by designing its controller. Okay, so the controller design, whenever you provide a start button, so that becomes the input signal to the controller that initiate the cycle, switches on the conveyor motor. So the start button switches on the conveyor motor, the conveyor is being continuously running. The sensor provide a input signal to the conveyor and that detect the presence of the high boxes. So these start button and the sensors are being connected to the input module of the PLC system. And we have a conveyor. The conveyor generate an output which sends a signal to switch off or switch on the motor, so that whenever the high boxes comes in position of the cylinder, and then DC valve solenoid again it is also generate an output signal that removes. So same thing, it's being pictorically identified as a signal. Now, so this entire activity are programmed by using a ladder logic diagrams in the PLC. So it is being generally developed by the Pico6 software. It is an open software that is being readily available. Alan Bradley PLC systems which supports different logical function like AND, OR, NOT, XOR gate. So by developing the logical system, so the PLC ladder logic are being developed. The input and output models are connected to the system devices in order to have an actuation. Yeah, for clear feedback of the system, we execute some delay period is being maintained between the various steps of the actuation of the physical system in the PLC. So the PLC signal provides to stop the motor operation, first actuation, as soon as it receives signal from the sensor. Then signal to start the motor is generated by the PLC after a particular delay period. So this can be easily seen in case of the signal flow diagram. So this is a ladder logic diagram. So the ladder logic diagram, how it is being built, these are the input model. So the individual details are being given in the system. The first ladder senses the high boxes coming on the conveyor and generate an output to motor off. The second ladder is signal sent to the DC valve in order to activate the cylinder in the forward direction. It is a cylinder to have forward direction. The corresponding solenoid of the DC valve will be energized, and that signal is being generated by the output model of the PLC system. Then there is a delay period is being mentioned. There is a small delay period is being mentioned. A timer will be on. So once the cylinder extension is completed, timer is on, and once the timer is completes its time, then the timer becomes an input, and the signal is sent to the DC valve for retraction, reverse action, and then signal is switches on the computer, switch on the motors. So this is where we have planned. So this is the signal. So here you see it is a sensory output. The sensor senses the signal. So high boxes. So when the sensor senses the high boxes, the output signal of the motor. So the motor is continuously switched on. Now it becomes off. So this is continuously off till the entire cycle of operation is completed. So this is a forward motion of the cylinder. So sensor is being sensed, motor is switched off, and conveyor stops, and the valve solenoid is activated, and the cylinder is being extended, and this pushes the boxes from the conveyor, and then there will be a small delay period. So this is the delay period that is being ensured. Then after that, the cylinder retract, and a corresponding solenoid, the return solenoid is being activated, and the cylinder retract, and thereby it completes the entire cycle of operation by pushing the high boxes from the conveyor, and then again the conveyor motor is switched on. So this is a signal flow diagram for the conveyor motor. These are the solenoid output signal flow, and this is sensory signal flow. Okay. This is the physical model that we have developed. You can see this is the proximity sensor. This is a conveyor system. Okay, so this is a high and low boxes are there, and here is the linear actuator system. Okay, so when the high boxes comes in the system, so the sensor senses the high boxes. Then once the high boxes is being sensed, the conveyor motor stop, and this pneumatic cylinder, this one, is being extended due to the actuation of the pneumatic valve, solenoid valve, and this extension pushes the high boxes from the conveyor system. So this is the way that the actuator removes the high boxes, and these are the low and the high boxes are coming on the conveyor. So this physical model also being generated in the systems. Okay, so the use of PLC systems have many advantages compared with the conventional relay system. In the conventional relay system, we don't have high flexibility because it is hardwired, and whenever we wanted to change this cyclic operation, we need to rewire it. But in case of the PLC system, we only need to change the program. The ladder logic program need to be changed. When it is being executed, automatically the system becomes ready. So the flexibility will be more, and the faster implementation of changes and correction as it is being softwired. Only changes in the program is required. Easy visualization of the process running, and increased operation speed. Speed of the operation, we use as a pneumatic actuator. It takes only a fraction of second to remove the boxes from the conveyor, and the operational speed will be very high. And the increased security and reliability and maintainability, and the reprogramming capability, and the elimination of hardwired control. So these are some of the main advantages of the programmable logic controller that we uses in the system. And the work can be also extended by employing multiple sensors in the multi-conveyor system for having a high automation. So the implementation of the system with the different types of DC valve is also possible, with only which requires only a little modification in the PLC programming system. So this is about the conclusion of the system. So that's all about the lecture, and if you have any doubts, you can ask me.
Thank you, sir, for your
Yes.
very good lecture, sir. We have Dr. Iqbal Rasif. He has one question, two questions, sir, basically. He wanted to know how to correlate big data with automation and manufacturing.
See, big data is another important area. Why its echo is coming actually? The
Sir,
hello.
sir.
Big data is another important area which extract the information of the automation or manufacturing system, which can collect the information. Only we need to analyze it. After analyzing only we have to implement the result of the big data system into the application. So the big data is nothing but a collection of different information of the ongoing process. And based on the information only, every time we cannot have an immediate action. So it is need to be analyzed, and which requires appropriate artificial intelligence system. And based on this output of the appropriate intelligence system, we have to take an output, and the appropriate action need to be implemented. So this is how the manufacturing way the big data need analysis before implementation. Anything more?
Yes, sir. He has one more question.
Yes.
What is the use of big data in automation? He wanted to know. Actually, he is a faculty of computer science engineering. So he wanted to what is the use of big data in automation? How he can use it?
The big data are being a part of the smart manufacturing systems, not exactly in, if not exactly in the automation. So the different information that we collect from the manufacturing system are being stored as a big data, and which can be analytically moved by using a cloud computing system. In the cloud computing, we basically interact the many of the different manufacturing sector together in order to have the experience of the data available from the one of the manufacturing sector, which gives an output, take an appropriate action can be implemented by the other manufacturing sector. So this big data will be interlinked, will be interlinked with the cloud computing system. The cloud computing is a system which interconnect many of the manufacturer in the cloud, and the implementation of one of the manufacturer data and appropriate action based on the analytical in the cloud big data, which can be directly available in the cloud, and the other manufacturer can be assess the data, and which he can implement. He need not to do conduct any of the experiment or anything else further in order to obtain the result for that. So that way the big data and along with the cloud computing, which can be used to in the manufacturing sector, because the cloud computing basically interlink the different manufacturers virtually on the cloud.
Okay, sir. Anything, Dr. Iqbal Rashid, anything else you want to ask? Fine. Sir, one question is from our TNP, Training and Placement. So they are, uh, uh, okay. What is the costing of PLC? Sir, Dr. Abhishek Kumar want to ask you, what is the costing of PLC?
So the it has depends upon the model, number of model, how many inputs and how many outputs that.
Okay.
Hello, could you
Yes,
able
sir.
to?
Yes, sir. Yes.
It basically depends on the number of inputs and the output of the BLC system. Okay, and 12 inputs and 12 output models. It's a very echo is coming. I don't know.
Will not come, sir. Yeah. Um, So this cost of PLC depends upon the number of this one, sir. Na?
Input and
Dr. Abhishek,
output.
input and output. So Dr. Abhishek, are you satisfied with the answer, or we should move ahead? Okay. One question is from Dr. Ashok Kumar, Ashok Singh. He is a professor of mathematics. He wanted to put one question, sir. He actually, Ashok Singh, sir, do you hear us? Okay. Sir, one question is from our TNP that they are working very hard, and of course, I appreciate and I thankful to them that they are fetching lots of job to our students. In fact, I must appreciate that every hand has a job, and few hand has more to them, more than one or two jobs. So, the basic problem what they are facing once discussing with me that industry and academy, that's what we teach and what they work, so there is a big gap between them. So how to educate or train our students right from the beginning, apart from the curriculum, so that they should be very versed with automation and sort of thing, especially I'm talking about electrical, mechanical and civil engineering students.
Arvind, could you able to
Sir,
hear me?
yeah, now I hear you, sir. So, do you get my question, sir?
Yeah, yeah, I understood. I
Okay,
understood.
sir. Okay, sir.
Okay.
As you know, sir, there's a weak mechanicals. They are losing interest. Not losing interest. There is. I think there is a paradigm shift now at this present moment. So while this is a shifting of, then obviously there will be a slowdown. But we have to work hard, and we have to take precautions. Ki how we should educate our students so that the academic and the industry, this gap should be filled up, sir.
Yeah, very correctly said. Actually, there is a great shift in the paradigm. And
Yes.
thing is that nowadays the pure mechanical and the electrical and the electronics nowadays being shifted to a interdisciplinary in nature. Okay. In order to have more interactive with the industry, so that basically the NBA is mainly intended to they focus on have a good coordination between the industry and the academic institution. So this is possible. Only thing is that whenever we revise the curriculum, so
Mm.
we also to incorporate one or more of industry people also in the curriculum development, so that their current and future requirement of the engineers and the educations that we need also can be taken into consideration in order to revise the curriculum. Because once we revise the curriculum, it will go for another 5 or 10 years. So whenever if we go with only the old syllabus and all, so that may not fulfill the requirement of the manufacturing industry or any kind of industry. So if they have idea or the input also taken into curriculum development, that is one aspect of making this. Another thing is that we also should develop the interdisciplinary programs rather than a simple mechanical, electrical, etc. We can BTech in mechatronics, and this particularly the automation which uses a mechatronic system, which requires a engineer having a knowledge of both of electrical, electronics, computer control, and many other aspects. So we need to develop the engineers in capable of tackling such kind of situation at the industrial world, so that we could able to have fulfill the requirement of the industry.
Okay. So any kind of suppose if we are not revising, that's the work of university to revise. At our institute, will you suggest some courses so
Yeah.
that we can have some 1 day or 2 days training sort of thing to our students, so that right from beginning itself we should train them from our end.
Yeah, that one refresher courses can be floated, and so that the you can invite the industrial people, or you can invite many of the academician, the latest trend in the industry and industry oriented job opportunity, and what exactly they need to develop themselves. These are the things you can have some refresher course as you discussed. And other than that, you also can send them industrial training. Is there in your curriculum industrial training?
Industrial training is there, sir.
Okay. In the industrial training, if a typical industry, if they go and in groups or individual, and they will learn something from the industry, and they usually when they return back, they used to give a seminar on that. And also some of the our group students also take up the project work from the industry related problems. When they work on similar kind of problems, when it is being can be implemented during the project, also they visit many industries, and when they visit many industries, they learn many things, and what exactly the current status of the industry, and there are many activity they come across. So that also will be one of the way that industrial related problem can be taken as a project work by the students, as well as corresponding guidance can be done by the faculty member.
Okay, sir. That's it. And in this 8th semester, sir, we have a full 8th semester. We have a project, and that according to our Jharkhand University of Technologies. So we are dedicatedly doing on mechatronics sort of things, sir. Trying to implement some automation into the manufacturing. So, Dr. Abhishek, you want to ask one more question? Please ask yourself itself. Okay. I have enabled your mic. So please ask, sir. Abhishek, sir. Actually, his query is, sir, can you suggest some book of PLC, because he is taking the book of PLC, sir.
Okay, there are many books are available in case of PLC systems, and I'll share with you through mail. Okay.
Yeah, sure, sir. And Dr. Ashok Kumar, please ask your question.
Hello.
I have allowed your mic, please.
Just I want to know what should be the role of mathematics in educating mechatronics.
See, mathematics is yeah.
What should be the role of mathematics in educating mechatronics?
Yeah. Okay, I understood. See, mathematics is there in every field of science as well as engineering, and mechatronics is not exception. So the mechatronics we use as artificial intelligent techniques. And the microcontroller, we have artificial intelligent technique. We have a system like the neural network, fuzzy logic, and other optimization technique in order to optimize the ongoing manufacturing process, etc. So these artificial intelligence techniques, we need to develop a algorithm, and the algorithm for which we need to solve a problem, which is really a mathematical kind. And without mathematics, we cannot have a complete science cannot be integrated. It is very much there in the mechatronics as well as in all kind of automation systems.
Okay.
Okay, thank you.
Thank you.
Now, anybody else want to ask question? Please raise your hand. Anybody? No. Okay, now I'll request our principal, sir, to give a vote of thanks to our Professor Dr. M. Chandrasekaran, sir. Principal, sir. Principal, sir, do you hear us?
बस 4 आदमी हो।
Sir, 1 second, sir. Actually, there is some problem, I think.
Okay.
So he will be connected just now.
To me. Can you listen to?
Yeah, Principal sir, do you hear us, sir?
I am hearing you, but you are not able to hear me.
Okay, now it's clear, sir.
Now it's
Sir.
clear.
Yes, sir. Actually, sir, today's talk is on a smart manufacturing use of mechatronics for a smart manufacturing, delivered by Dr. M. Chandrasekaran, Professor Mechanical Engineering, NERIST, Arunachal Pradesh. So, and Sekharan sir, I'll introduce our principal sir. His principal sir is Dr. T.K. Das, principal of our college, RTCIT, Ranchi. So, principal sir, please.
Good morning, Professor Chandrasekaran.
Chandrasekaran sir,
other
it will
faculty
be
members.
good to if you open your camera, sir.
And other faculty members. It's a pleasure to me that I could participate in your session for some time. I was hearing a question answer session. It was very good and quite encouraging. And the topic you have covered, it's a really challenging topic and topic of today. Since we are affiliated in institute, changing of syllabus may not be very easy. But anyway, the other options you have mentioned on certain aspects, that organizing the special lectures or maybe add-on courses, that might be possible. I think we will be, as mentioned, we will be taking care during sessions. We are thankful that you have agreed and delivered your session lecture, and participants are fully satisfied or benefited through this. Ormanjhi and Jayaprakash, I also thankful to you both to organizing this and providing the opportunity for our faculty members to upgrade themselves. Thank you very much. We'll be having another
thank you,
day.
sir. Thank you, sir.
Okay, thank you. Okay.
Thank you, sir. Thank you for inviting us and giving me an opportunity to interact with you, faculty members. Thank you very much.
Thank you, sir. Thank you, Principal sir, for your vote of thanks. Thank you, Chandrasekaran sir, for this wonderful lecture. I hope that all our participants have enriched their knowledge in mechatronics. Sir, I'll request you to kindly share your PPT with us so that I'll share this to our participants. And on behalf of you, I make announcement that if any of our participants need any kind of support from you, I think your door will be open to them, sir.
Okay.
Yeah. So thank you very much, sir, for giving your time, sir, for us. Thank you very much, sir. Thank you, sir. Thank you.